So we'll get started. So this is going to be lesson two, and we'll be talking about the easy calculation of rational numbers. So essentially, you can expect that we are learning about different techniques on easy calculations in today's lesson, all right? So let's take a look at the first exploration. So what can you observe about this calculation? Well, you can leave your answer in the chat box. So anything special about this calculation? Minus. Lots of numbers, yes, there are lots of numbers. Of course there are. But then the thing is, what I want to say is that you can observe that this number, this calculation is formed by 3 multiplications, which all of them have the same multiplier. All of them have the same multiplier, right? Which means that if, let's list a simple example. For example, if I have 1 times 2, adding 2 times 2, take away 3 times 2. That's going to be 2 adding 4, take away 6, right? Which is 0. But then, if you extract the common multiplier 2 from all of them, it's equal to 2 times 1 adding 2, take away 3, right? 1 adding 2, take away 3. So that works the same way in this question if we are extracting the common multiplier. So let's see how it works. First of all, the first step is to write down the common multiplier, which is minus 12 and 9 over 16. All right, that's the common multiplier. And then after that, after we have written down the common multipliers, the next thing you do is to write down anything that is remaining, including the numbers and addition or the subtraction. And then write them in brackets. So we have minus 8, take away minus 5, adding 4 in brackets. And the final step, the third step, is to multiply them together. And that's how you can complete the calculation. So essentially, the next step is going to be just copying the common multiplier down again, because we want to work on what's inside the brackets first. So minus 8, take away minus 5, which is going to be add 5, add 4. So we have minus 8, add 5, add 4, which is 1. So we have minus 12 and 9 over 16 times 1, which is itself. All right, so that's going to be the answer to the first exploration. Does it make sense? So that's the first technique we are talking about today, extracting the common factor or extracting the common multiplier in an expression or in a calculation. Basically, 3 steps, and we can figure out the answer to these questions. First step is extract the common multiplier. Write it down. That's it. The second step is circle all the remaining numbers together with the addition or subtraction signs and put all of them into a bracket. The third step is to multiply the bracket and the common multiplier. That's how you can get the answer. That's how you can get the answer for these type of questions. All right. That's okay. Why? Sorry about taking notes, Remy. That's completely fine. Yeah. All right. So that's the trick we are learning as the first one today. So the next one, exploration 1, question number 2. When you're looking at this question, do you spot any common multipliers? Well, we have Oh, yes, that's right. A nice and precise circle there. Exactly. So we have minus 11 and a seventh, minus 11 and a seventh. But then we have 11 and a seventh without the minus here. So what can we do first? We know that if I want to extract a common multiplier, I need a common multiplier, which means that I want to turn this into minus 11 and a seventh. But then, of course, I can't just flip the sign of it without doing anything else, right? So I need to multiply it by another minus 1, which means that what I'm taking away is 6 times minus 11 and a seventh times minus 1. So that's equal to what we have here, which is equal to minus 6 times minus 11 and a seventh. All right, so that's what we are taking away, remember. So the sign is really important. And then we can extract the whole thing, minus 11 and a seventh. Yeah, that's right. You can turn 6 negative, of course. And then that's the first step. The second step is to write down every number that is remaining. 5, take away 4, take away minus 6. And put them in brackets. 5, take away 4, take away minus 6. Which is equal to minus 11 and a seventh times 5 take away 4 adding 6, which is equal to 7. So now we can just try to turn this mixed number into an improper fraction, which I have minus going first, and then I'm just turning 11 and a seventh into an improper fraction, which 11 times 7 is 77. That adding 1 is 78. So we have minus 78 over 7 times 7, which you can see that the 7s are going to cancel out with each other, which means that in the end, I'm going to get the answer as minus 78. All right. Does that make sense to you? So technically speaking, this is no different as the previous question. But then for these kinds of questions, something that you need to notice is the sign or the operation. If you don't want to get it wrong, well, I know that it's going to be pretty easy if these are all integers or like these are all positive numbers. But then the thing is, if you don't want to get it wrong, always try to bring along the signs with you when you are doing the operations. So you need to imagine that the plus or the minus signs are replacing the addition or the subtraction. So what I mean is that you need to think about this as -4 instead of take away 4, right? Such that you are binding or associating the sign together with that number. And that's one of the key ways to avoid making mistakes related to the sign changes, all right? So that's one of my personal secret tips. This is super useful. And later, if I have a chance, I'll just try to demonstrate it to you a few more times, such that you are understanding better what I mean. All right. But let's take a look at exploration 2 first. So what about this one? Can I use the same method as the previous ones in this question? So it just requires a little bit of knowledge we have from lesson 1, which is the powers. Yes, we definitely can. Yes, that's right, Yuki. 2018. 2018 squared is just 2018 times 2018, right? And then we are taking away 2018 times 2017. Which means that first of all, we have the common multiplier 2018. And we can write it down first. That's the first step, write down the common multiplier. The second step is to circle up whatever is remaining and together with the signs, write them in the other bracket, 2018, take away 2017. And finally, multiply them together. So we know that it's going to be equal to 2018 times 1, which is just 2018 itself, right? Yes, exactly. That's very good. So basically, you just need to, do a little bit of conversion to the condition given in the question, or like the expression in the question, and you're gonna get it. So that's just how you work this out, right? That's exploration 2. And let's take a look at this one. This one is slightly trickier. So I'll just give you 20 seconds to take a look at it. All right. Okay. Yeah, so many of you are seeing 2015 there, right? But then the thing is that not every single term in here are associated to 2015. For example, this one and this one, yeah? So they are not really blending in with the 2015 thing. But don't worry, we can just try to do it with the 2015 first and then see what's going to happen. Why not? Well, because we can see that 2015 is in different powers. Even if I want to associate this with 2015, the thing is that I have to extract one factor of 2015, and then the remaining of them are also going to be 2015 squared, for example. So that's still going to be a really large value, right? So, well, if I find out that something is not, well, you can try. If I try to work it with 2015, it means that I need to take away 2015 and then adding 2, right? Which means that even if I can conclude these 3 terms by a common multiplier of 2015, I still have a single 2 right there. Despite, well, the complexity that is going to spend you when you're connecting it with 2015. All right. So it would be a bad suggestion to go right ahead with all these terms together, which means that I can just try to do it bit by bit. Firstly, I can see there are 2 terms with 2015 at least. And to be more specific, 2015 squared is their common multiplier. If you can discover that, it's great. If you can't, you can also try to split 2015 first and then 2015 again. All right. But for simplicity, I'm just going to extract it directly. All right. So we're going to have 2015 squared multiplying 2015 take away 2. That's what's going to happen. And don't forget that I still have subtracting 2013. The same goes for the denominator. So because we have 2015 to power 3, adding 2015 to power 2. So that's going to be 2015 to power 2 times 2015, adding that times 1. So 2015 times 1. And then we are taking away 2016. But is that making things any simpler? Well, not unless you are calculating what's within the brackets. This is 2013. And this is 2016. So in the numerator, I have 2013 multiplying 2015 squared, take away 2013. In the denominator, I have 2016 multiplying 2015 squared, take away 2016. Which means in both the numerator and the denominator, now we have a new common multiplier, which is 2013 in the new numerator. It is multiplied to 2015 squared and take away 1. For the denominator, the common multiplier is 2016, which is multiplied to 2015 squared, take away 1 as well. So now we can see that in the numerator and the denominator, we can divide the same term such that what we have remaining is 2013 over 2016. All right, does it make sense? So this one might be a little bit complicated, but hopefully you are understanding what's going on here. All right, cool. That's nice, that's nice. Okay. So in that case, let's move on to exploration 3, which we are going to be talking about the other method. So in exploration 3 here, we have a grouping method. Basically, if you look at sub-question 1, are you able to calculate a half to the power of 2016 or minus 2 to the power of 2017? Any one of them with your bare hands? I don't think so, right? It's pretty much impossible for anyone to calculate such a large power without any help of a calculator. Yeah, definitely. But we don't actually need a calculator here. We don't actually need a calculator. We can definitely calculate these questions without the help of a calculator. Because the first data is we know that this equation 1, or like this question 1 here, is equal to 1/2 times 1/2 times 1/2, and I'm multiplying 2016 of 1/2, right? And then I'm multiplying that by minus 2, by minus 2, and by 2017 of the minus 2s. And then I'm subtracting 1 from it, right? Yeah, so, well, if you split it up, you can see that every single one of the 1/2s, multiplying every single one of the minus 2, is equal to minus 1. So how many groups like that can I form? We know that we have 2016 of 1/2s, but then one more of the minus 2s, which means that, well, definitely the fewer one is limiting the number of groups you can form, right? So it means that in the end, we are going to have 2016 groups of whatever that is, minus 1, multiplying the singled out minus 2, well, sad, and take away the 1, which means that I have minus 1 to the power of 2016, multiplying minus 2, take away 1. What is minus 1 to the power 2016? We have just learned about that yesterday. Yes, to the power of 2016. It's not multiplying 2016, right? So it is 1. 1 multiplying minus 2 is minus 2. So we have 1 multiplying minus 2, take away 1, which is minus 2, take away 1, which is minus 3. Yeah? So that's the power of grouping methods. You see, there are 2 prerequisites when we're trying to do the grouping method. The first one is to make sure that each group is easily calculable. All right. And then the second one is to make sure that each group has the same outcome when you're trying to calculate it. Once it satisfies these 2 conditions, you can use the grouping method. Yeah. Thank you for all sorts of weirdly looking -3s in the chat. Very helpful. All right, so sub-question 2. And we're going to have 4 terms multiplying together. One of them having a power of 1,999, the other 2,000, the other 99, the other 100. Which 2 do you want to group together? And why? So what are you going to group here? Very good. First 2 and last 2. Because that's easily calculable, right? And also, if you're looking at the number of the powers, like if you're looking at the power numbers, that's going to be pretty much of the same scale for the first 2 and of the last 2. So you can imagine that they're going to be operated somehow, right? So for the first 2, we have -1/3 times 3, which is equal to -1. Yeah, that's what's the outcome for the first 2 terms for each group of them. And then for the second 2, like for the last 2, if I have 3/4 multiplying -1 1/3, it's equal to 3/4 multiplying -4/3, which is again equal to -1. Okay. So that's what we have right now. Don't forget about the minus. Don't forget about the minus there, Anthony. So it means that now I can rewrite this equation as, for the first one, we have 1,999 sets of -1s multiplying 3, because there's 1 3 singling out, as 2,000 is 1 more than 1,999. Right. And then for the last 2, we are multiplying -1 again, because each group is -1, and there are 99 groups of them. And this time there's an extra -1 1/3. All right. So the next step is, we know that -1 to the power of 1,099 times -1 to the power of 99 is equal to -1 to the power of 2,098, right? So is that positive or negative? You still remember what we have learned yesterday? Yeah, that's going to be positive. Or of course, you can analyze them one by one. Like each of them are negative, and the 2 negative ones are going to be multiplying to give a positive one. But if we can already combine them together, if you know how to operate the powers, that's going to be more convenient. And then we are multiplying 3 and multiplying -4/3, right? So conveniently, the 3 and the 3 cancels out with each other. And what we have remaining is going to be +1, which is 1 times -4. which is equal to -4. So that's going to be the answer to the second sub-question right here. Yeah, that's right. So does it make sense to everyone? Is that all right? Yep. Okay. So exploration 4 is a little bit unrelated to this method, which is the reason why I'm skipping it first. So let's take a look at exploration 5. In this question, would you just try to add all these numbers up from 1, 3, 5, so all the odd numbers from 1 to 99, and then subtract all the even numbers? Yeah, so I can see the answers scribbled on the board somehow. No, we're not doing that. That's going to be pretty dumb, isn't it? Use the Gauss thing. You mean like the sum of the arithmetic progressions? Ah. Nah, not that either. Just to remember the grouping method that we have just learned. Would that help here? The grouping method. We know that I'm adding all the odd numbers and subtracting all the even numbers, right? And we know that these are going to be alternative, which means that if I bind 1 to 2, I bind 3 to 4, I bind 5 to 6, rearranging all of them, I'm going to get 1 take away 2, adding 3 take away 4, adding 5 take away 6, all the way to 99 take away 100, right? And we know that each 2 of them is going to be one group. Yep. So what is the sum of each group? As I said, there are 2 prerequisites, right? The first one is that each group should be easily calculable. And step 2, we need to make sure that each group have the same sum, such that we can conclude it. Yeah. So yes, that's right. Each group has a sum of -1. And how many groups do we have altogether? Well, we have 100 numbers, and then there are 2 numbers in each group. So we have 50 groups altogether, right? Which means that the answer is going to be equal to -1 times 50, which is -50 groups. Easy, yeah? What about the last question? Well, not technically the last question, but the second question for exploration 5, because later on we're still going back to exploration 4 there. So for exploration 5, well, this time, observe this question really carefully. We have 1,000 adding 999, subtracting 998, and then adding 997, adding 996, subtracting 995, so on. So what's the pattern here? Are we still adding 1 and subtracting 1 in each group? So do you still have 2 in a group? Yeah, that's right, Vicky. It's going to be add, subtract, right? So 2 additions and 1 subtraction, or 2 positives and 1 negative, which means that if the pattern goes like that, how many numbers should be in each group? That's okay, gotta go English lesson. All right, go for your English lesson. Yeah, 3, right. There's going to be 3 numbers in each group. And well, because the last one is a subtraction term, I totally agree that maths is more important. But then, well, I'm definitely not forcing everyone to agree with me. So it's their freedom. to leave or join. But back to this question, because the last term is a subtraction or a minus term, it means that it's going to be complete groups, right? It's going to be complete groups. So how many groups are there from 1,000 to 101? How many groups are there in total? 300. Yeah, that's right. Because we know that the number of numbers from 1,000 to 101 is 1,000, take away 101, adding 1. And that divided by 3 is going to be the number of groups, which is 300, because that's 900 over 3, right? So we have 300 groups. But now, is each group having the same sum? Not this time. So it is slightly different from what I have concluded earlier, right? What I have concluded earlier is that, well, if they have the same sum, I can put them into groups. But then here we can see that if they have the same pattern, we can also try to put them into groups, because we can still find each term manageable. Because you can see that the first term is going to be 1,001. The second term is going to be 998, because every time you can just try to calculate the 2 numbers there first, and that's going to be 1, right? So each time you just need to add 1 to the first number, and that's going to be a sum, which means that this is going to be an arithmetic progression, taking away 3 each time, right? And all the way until that we have 107 and 104. So now we can just try to use, we can just try to calculate the arithmetic progression here as a sum of the arithmetic progression, because we know the first term, we know the last term, and we also do know the number of terms, which we have just found. So we can just use the formula for the sum of arithmetic progressions, which is the first term. Well, you can start either way. So 104 or 1001 both works. Adding 104. So the first term adding the last term. That multiplying the number of terms, 300, divided by 2. Yeah, Anthony, and do remember the brackets, because you need to do the addition first, all right? So we have 1,105 times 300 divided by 2, which is equal to 331,500 over 2. And that's going to be equal to 165,750. Yep. Hopefully I'm doing my mental maths right. Yeah. So that's going to be the answer to this question. Does it make sense? So any questions from anyone? No? All right, yeah. So basically, as long as you know the formula, as long as you know the formula for the arithmetic progression, you should be able to calculate this, all right? So you can see that if they are of the same pattern, you can also use the grouping method. The grouping method is one of the very, very useful techniques we can do in fast calculation, especially when the numbers are at a scale which you cannot possibly calculate directly, all right? And then finally, we're just going to exploration 4, which I'm going to cover it really quickly. So what is a good approximate for this number? If you find it a bit hard to calculate, you can just do an approximation to this number. Yes, that's right. That's right. We can see that it is very, very close to 100, right? But because we are doing a calculation, we know that it's not exactly 100. Yeah, by 1/72, exactly. So first of all, we can just try to write it as 100, take away 1/72. And then I'm multiplying that to minus 36, which by the distributive law of multiplication, we can just multiply minus 36 to each and every term, including the signs, of course, inside the brackets. So that's going to be equal to minus 36 times 100. Take away 36 times minus 1/72. All right. So for minus 36 times 100, we have minus 3,600. And then if I have minus 36 times minus 1/72, I have adding. And that simplifies into 1 and 2. So we are adding a half. What is minus 3,600 adding a half? Is it 3,600.5? Yes. If you're adding a value to the negative number, the numerical value of the negative number is going to get smaller or closer to 0. All right. So it will be minus 3,599.5. Okay, that's the answer to this question. Easy peasy. So that's everything for today, kids. How well are you accepting it from a scale of 1 to 10? Let's do a quick survey. Nice. I can see that you're already confident about this. All right, that's good. That's good. That's good. So I'm just gonna send the practice question into a group chat later, and you can just try to work it out after this. All right. So everyone, see you tomorrow. See you tomorrow for the last lesson. It's gonna be on SIRS tomorrow. Yes, Siru, tell me about your question. I'm just gonna wait. I'm just gonna stop the recording now.